Morning. Today we are going to see the next part, that is of oral questions on MOS, or you can say SOM. You can go to playlist, and in that playlist you can see we have this MOS oblique SOM oral question preparation, and from this you will get different videos. Around 10 videos I have uploaded over here. So now we have seen till bending stresses. So now we will go to the next, that is torsion. So bending shear stresses already we have done with. Now we are with unit number 4 questions, that is torsion. Now the difference are generally asked for bending moment and torsion. So when bending moment is in the plane of the member, means if you will apply load to the member and then bending moment will be developed. We have this will be P by 2, this will be P by 2. And whatever bending moment diagram you are going to plot over here, that bending moment diagram is in the plane of the member. And when moment is in the plane of the member, that moment is known as bending moment. So bending moment is in the plane of the member. In the plane of the member. And second we have, that is torsion. So now how this torsion that will be developed. So try to understand now this. We have this will be beam and a cantilever is applied to it. This cantilever is perpendicular to this member and then load is applied on this. So we have this will be load P and this is L, or we will say A. And then whatever moment is developed, so that moment is known as torsional moment. So torsional moment perpendicular to the plane of the member. Perpendicular to the plane of the member. So examiner may ask, so you should be in position to explain both the diagrams, that is in the plane and perpendicular to the plane. So this is first part. Then we have torsion. What is formula of torsion? So we have T is equal, T by J I will say, which is equal to G theta by L, and that is equal to tau by R. This is torsional formula. So he may ask, compare torsional and flexural formula. So we will compare. Before this, we will explain all the terms and their units. T we have torsional moment. Torsional moment unit is Newton millimeters. Newton millimeter. Then J we have polar moment of inertia. Polar moment of inertia. Unit of this is mm to the power 4. Now we have G, shear modulus or modulus of rigidity. Shear modulus or modulus of rigidity. Modulus of rigidity unit all modulus have same unit, Newton per mm square. We have three modulus. One is Young's modulus, then we have G shear modulus, K bulk modulus, and all these moduli have same unit, Newton per mm square, or Pascal, and Pascal we have Newton per meter square. Then we have theta, this is twist, and unit is radians. Radian. How to convert radian into degrees? So we have to multiply by 180 by pi, radian to degree, and degree to radian, pi by 180. Then we have L, unit is radian, L, length of torque, meter or millimeter. Sorry, length of torque, not length of shaft. Unit is millimeters. Tau, we have shear stress. Unit is Newton millimeters. So we have unit Newton per milli. All stresses we have Newton per mm square, are radius of the shaft in millimeters. Radius of shaft in millimeters. So likewise, we should know all this. Now we will compare flexure and torsional formula. So we have, this is flexural and then torsional. Now we have M by I is equal to sigma by Y is equal to E by R. Now here we have T by J is equal to tau by R is equal to G theta by L. So we have M bending moment, unit Newton millimeter, torsional moment, unit Newton millimeter. I, moment of inertia, J, polar moment of inertia. What is polar moment of inertia? As T is perpendicular to the shaft, J is also perpendicular to the shaft. That is along z-axis. We have, this is x-axis. We have y-axis. And perpendicular to this. So in this way, that is perpendicular to your computer, we have z-axis. So this is y, and perpendicular to the screen, we have z-axis. And IZZ is nothing but J, and that is equal to Ixx plus Iyy. And we have Ixx plus Iyy, pi by 64 d4 plus pi by 64 d4. And if we will add this, we will get it as pi by 32 d to the power 4. And mi, we have Ixx or Iyy, depending upon the load, and we have this Ixx pi by 64 d to the power 4. Sigma, we have bending stress. Bending stress. It is linear. Tau, we have shear stress. Shear stress. It is parabola. Then we have Y, distance of the fiber from neutral axis. Distance from neutral axis. R, this is a radius. So this is maximum at surface. So this is a radius of shaft. G, shear modulus. Shear modulus. E, Young's modulus. R, radius of curvature. Radius of curvature. And theta by L, twist per length. Twist per length. So likewise, we have this will be combination, that is of, this is combination, or we will say comparison of flexure and torsional formula. So we have, this will be the questions. Now you may ask, draw the shear stress diagram by shear stress and then by torsional moment. So now I will plot shear stress diagram due to shear stress. So we have, this will be for circle, this will be shear stress distribution diagram. Shear stress distribution diagram. Distribution diagram by shear. We have formula, if you remember, we have tau is equal to VA y bar upon IB. We have seen this, and tau directly proportional to y bar. So it is parallel. Now, if you will draw this diagram, that is for torsion, then how we will have this diagram? So we have value. Now you can see we have T by J is equal to tau by R, small r, and that is equal to tau max by capital R, which is at surface. And then we have tau, this is equal to T by J into R. Now this T by J is constant, and we have tau directly proportional to R. Same, if you will see, M by I is equal to sigma by Y, and we have sigma is equal to M by I into Y. So sigma directly proportional to Y, so linear. And here we have same fashion, that is linear. So you have to keep in mind shear stress diagram for torsion and shear stress diagram for shear, we have different. And now we have this as shear stress diagram. So this is shear stress due to torsion. Shear stress diagram due to torsion. Due to torsion. So we should be in position to differentiate all these, and we should know what are the different terms related with this. So now we will stop here for torsion. So remaining part we will see in the next lecture. Thank you.